Financial Modeling, Topic 17, Delta Hedging. Section 4. Understand the relationship between realized and implied volatility and delta hedged profits. In the last example, our implied volatility is 8.67%. That's an annualized implied volatility. The daily dollar implied volatility would be the 18.67% divided by the square root of 252. That would give you my percentage daily standard deviation. Multiply that times the current spot price of 614. In other words, a 1 standard deviation move in that stock for 1 day is $7.22. Now, if that daily change in the stock price is 1 standard deviation plus or minus 722, then the realized standard deviation over the life of the option will be exactly 18.67%. What that means, if I just take minus 722 and plus 722, and minus 722, and so on, and I calculate the percentage changes on that $614 option, when I calculate the realized volatility of those changes, they would exactly be equal to 18.67%. So the delta hedge profits will approximately break even if that realized vol is equal to the implied vol. So as long as there's a plus 722 or minus 722 dollar change in the stock price, I break even. So let's go back to the daily P&L we just had. And the only change to my last spreadsheet is I rounded it to 50 shares. So I bought a call option on 100 shares of Goog at $6.15 for March maturity. I shorted 50 shares of stock to execute my delta hedge because my delta is 0.49. Now in this example, I had the stock price falling by 1 standard deviation, 7.22, $7.22, and it's 1 day older. And what I showed is we basically break even. My P&L is broken even. In other words, the call profit would have been down about $360, mainly because of the time decay and the stock price falling. However, that's offset by the gain in that short position in 50 shares. Now let's think about this a little bit more carefully, and we'll go back to that return attribution. So if I look at the return attribution of the option, why did I lose $360 on 100 shares on that option? Well, we've lost $360 because of the delta. We gained $39 because of the gamma of the option. We lost $40 in time decay because it's 1 day older. So those are the factors that explain why we would have lost about $360. And that is almost perfectly offset by the gain in $360. One way of thinking about my reason why I broke even for 1 standard deviation change in this stock is if I look at the delta of the option profit and I look at my P&L on just the short position in stock, they perfectly offset. And the reason they perfectly offset is because we took a position, an exact position in delta shares. However, what gets a little messy here is I have a gamma P&L and I have a time P&L. And what we see is they perfectly offset. So one way of thinking about the P&L on this position for 1 standard deviation change in the stock, in other words, based on implied volatility, is the delta of the option offsets the delta of the stock, and the gamma of the option offsets the time decay, and I break even. Now, what reason I like to think about the P&L on a delta hedge in this manner is for any change in the stock that's larger than 1 standard deviation, say minus $10 or plus $10, what's going to happen is the deltas are always going to offset each other. The delta of the stock and option are always going to offset each other. The time decay is not going to change for a bigger change in the stock price. So for any bigger change in the stock than $7.22 in absolute value, what's going to happen is the gamma effect is going to get bigger. Remember, it's the gamma effect is 1/2 times gamma times change in stock price squared. So it doesn't matter if it's positive or negative change. As long as there's a larger change than 722, this number is always going to be larger than $39.92. So the reason why you're going to gain is because your gamma is going to offset your theta, and you've already eliminated your delta risk. I'll say that one more time because that was pretty nasty. if you delta hedge a stock, you've eliminated your exposure of delta, meaning that the delta of the stock is equal to the delta of the option. The remaining risk of time decay, that's going to happen no matter what. And for a 1 standard deviation change in the stock price, the gamma positive effects are going to offset that time decay. And for any larger change in the stock price than 1 standard deviation, this gamma is bigger than this theta effect, and I'm going to make more money. Now, if I just do this graphically, if I took a position in a call that has this type of exposure, and I offset it with a short position in delta shares that has this type of exposure, when I add those two positions together, I get this delta hedged portfolio, which is delta shares and the stock. So I have call minus delta shares. I said minus the stock. Now let's think about these graphs. This is a profit graph 1 day later based on what the stock price is 1 day later. Remember, the initial stock price is 614.27. Now notice, if it's 1 day later and the stock price doesn't change, I have no P&L on my short position. However, if it's 1 day later, my call is going to lose this amount of money. That amount of money is theta. It's my time decay. However, for a large change in the stock price, say this point and this point, or not a large change, a 1 standard deviation change in the stock price, what's happening is the gamma, the curvature P&L of this call is offsetting its theta, or its time decay, and I start making money. And any change greater than 722, or any change worse than losing 722, that 1 standard deviation in the stock price, that gamma effect, this positive P&L, because this is curved, is offsetting this theta. So here is my net profit position from a delta hedged long position in this call, that if I have anything less than a 1 standard deviation change, my time decay loss is greater than my gamma P&L, and deltas are offset. So I'm going to lose every time there's a stock price change less than 1 standard deviation in either direction. However, I'm going to win anytime there's a stock price greater than 722 in either direction. So that becomes my net P&L on this delta hedge position. I just put on the delta hedge and just hope for big changes, and that's how I'll make money. So that is the relationship between realized volatility, what happens after we put on the delta hedge, its implied volatility, and our delta hedge profits. I'm just hoping for big changes if I own the option.